All right. Hello, everybody, and thank you so much for joining us for today's webinar brought to you by Mix It Up from Bayer Crop Science. My name is Michelle Allison, and I'm the group publisher of agriculture here at Annex Business Media, representing Top Crop Manager magazine today. Today is the last of 3 installments of this year's Resistance Management webinar series, and I'm joined today by Dr. Brianne Tideman, research scientist with Agriculture and Agri-Food Canada, based out of Lacombe. Today, during our session, Brianne will go through different tools and practices she has been researching, like harvest weed seed control, and what her research has found. She will also touch on new studies on older techniques like seeding rates. Thanks to Mix It Up by Bayer Crop Science for sponsoring our session today. From seed to harvest, Bayer is focused on delivering top-performing solutions to address some of your toughest farm challenges. This webinar is being recorded and will be made available to all attendees and registrants approximately 24 hours after the live broadcast. This session is scheduled to run for approximately 45 minutes, and following Brianne's presentation, we'll open the floor for questions. If you have any questions throughout the presentation, please type them into the questions tab found on the GoToWebinar panel on your computer screen. This webinar has been approved for 1 CCA CEU credit in integrated pest management, and further instruction will follow the presentation if you did not include your CCA number on the registration form. So without further ado, I'll let you take it away, Brianne.
Perfect. Thank you, Michelle. Good morning, everyone. We are just going to jump right into things because this is a topic that I could talk about for a very long time, and we don't have that much time this morning. So I just want to start by thanking all of the groups that fund the research that you're going to see today, including Alberta Canola Producers, Western Grains, Sask Wheat, Alberta Wheat, ACIDF, NSERC, and Redicot. And I also need to say a big thank you to the summer students, the co-op students, and the technical staff that I work with. As you'll see in the presentation, some of the work that we do is not necessarily the most fun to get the data that we need to discuss some of these research studies. So a big thank you goes out to them for giving me something to talk about on these types of webinars. So I'm going way back to the start just to sort of set the frame here and give you a bit of an explanation of how I'm looking at this topic. So we all know weeds are crop pests. They affect our crop yield, our crop quality. The dominant global weed management practice, so across the world, is herbicide application. That is our primary method of managing weeds in agriculture. And herbicides tend to target weeds either at the seedling stage or upon emergence. So I have this very technical, very little diagram where we have a seed in the seed bank that emerges and grows into a seedling, which, if it survives, matures into an adult, which produces new seeds, which go back into the seed bank. And so when we're applying herbicides, we're really trying to target this seedling stage here, or sort of the emergence of the seed into a seedling if you're using a pre-emergence herbicide. So this has sort of been where our focus is in the weed life cycle for management of those weeds. A lot of the techniques that I'm going to show you, or the tools that I'm going to show you, are working at a different part in the life cycle. Now, do we need non-herbicide management? My opinion is obviously yes. This is the increase in unique resistant weed cases for Canada. This was last updated in 2019, this particular graph. We are now well over 70 cases of herbicide-resistant weeds in Canada. And of course, we are not alone. We rank third in terms of herbicide resistance behind the United States and Australia. But unfortunately, this isn't necessarily a bronze medal that we really want. So with increasing herbicide resistance issues, a limited introduction of new herbicide modes of action, we need to start looking at other non-herbicide options for management of those weeds. So what herbicide alternatives are there? These are the big ones that I'm going to talk a little bit about today, focusing on sort of two groups, either cultural controls, so looking at things like crop rotation, increased seeding rates, perennial or forage crops, as well as physical controls. So I'll touch very, very briefly on inter-row tillage, but we'll focus more on panicle clipping and harvest weed seed control. So I want to start by talking about some cultural systems trials. Now, these are trials that were initiated by Dr. Neil Harker, my predecessor at Ag Canada and Lacombe, and looking at integrated wild oat management. So the treatments that he included in this study, there was two options for direct seeding rotations, either continuous barley or a barley canola, barley pea rotation. There was two different types of barley cultivars, either a short or a tall, with the tall one being a more competitive cultivar in this case. two seeding rates, 1x or 2x, and our 1x seeding rate was 200 seeds per square meter. And then a quarter, a half, or 1x full rate of either an ACCA's or an ALS wild oat herbicide. Now, this was at a time when we were still sort of looking at whether or not we could cut herbicide rates and still effectively manage our weeds. This is not something that is recommended currently. However, you could look at the quarter or the half rate as populations where maybe there's some resistance so that you don't get a great kill with those herbicide applications. Sorry, I'm just going to back up here. The treatments are applied to the same plots year after year after year, so we are looking at cumulative treatment effects. So we're going to look at year 5 when everything's in barley and you're seeing the effect of all of those treatments over the previous years. So this is what it looks like, either straight barley or barley canola, barley pea, but in year 5, both rotations are in barley so that we can compare apples to apples in terms of our wild oats. So looking at our wild oat biomass at barley maturity, this is at the quarter herbicide rate, just so that the herbicide is relatively limited here. So if we look at the continuous rotation, what we see is as we increase the height of the barley or we increase the herbicide rate or both, our wild oat biomass decreases quite substantially throughout those continued increases in integrated weed management techniques. Now, if you add a more diverse rotation into that, the wild oat biomass starts out lower right off the bat from using a rotation, and all of those values for each of those treatments is lower in a rotation system, down to 82 kilograms per hectare from our highest of 1,531 kilograms per hectare. So that is a substantial reduction using just integrated weed management techniques. Again, this is the quarter herbicide rate, so this would not be due to the herbicide management component. Now, if we look at this in terms of each of those factors, so if you do only one thing, you just increase your seeding rate, you just move to a more competitive variety, or you just move to a rotation, you reduce your wild oat biomass by about 2 to 3x. If you do 2 of those things, it's a 6 to an 8x reduction in wild oat biomass, and if you do 3 of those things, we end up with a 19x reduction in wild oat biomass. So you can see that it's not an additive effect. You don't get 2 to 3 times from each thing you do, but it actually becomes synergistic so that you can really increase your management of wild oat. Now, that's not to say that using these factors will wipe out your wild oat population. That's not at all what I'm saying, but as you can see, they can have a huge impact in helping to manage those wild oats. So here's a quick picture. This is our short barley seeded at 200 seeds per square meter. Straight barley for 5 years at a quarter herbicide rate. Here is our tall barley, our increased seeding rate in rotation, again a quarter herbicide rate. And you can see the huge difference in terms of wild oat pressure between those two plots or those two treatments. And those pictures were taken on the same day in 2005. Now, the next question Neil asked is a barley canola barley pea rotation really diverse? It's all spring annual crops, so what could potentially be better? And this moved him into his next rotational study. So he developed a new study with more diversity. So they supplemented natural wild oats in the fall and spring of the first year, and his goal was to combine optimal cultural wild oat management tactics with truly diverse rotations, not just summer annuals, under a no-till regime. So he had 14 treatments, and that included a 100% herbicide canola wheat check, a chem fallow check, and an alfalfa or a 3-year perennial check. All plots received their full rate of dicot herbicides. Again, we're just focused on wild oat here. We had 4 reps at each site, and we had 8 locations. Now, these 8 locations, there was 3 in Alberta, 2 in Saskatchewan, 1 in Manitoba, 1 in Ontario, and 1 in Quebec. So quite a diverse set of environments that this study was conducted at, and of course a huge number of collaborators involved as well, for which we are very grateful for their assistance on this project. So just some pictures to get started. This is a 2013 plot. This is a 2x seeding rate of spring wheat with 0 wild oat herbicides applied. Prior to this year, we had 2 years of early cut barley silage, again with no wild oat herbicides. So you do see some wild oats in here, but the pressure isn't actually all that bad compared to even the barley picture that we saw previously. Compare this to a 2x winter triticale, again 0 wild oat herbicides. And that was preceded by an early cut barley silage and a 2x seeding rate of winter wheat, both with no herbicides. So this is 3 years with no wild oat herbicides, utilizing winter cereals and barley silage, and that is a very clean crop of triticale in terms of wild oat pressure. So looking at some of the other treatments that were involved, this is looking at wild oat emergence, or the counts in terms of the population. We're going to compare everything to the canola wheat 100% herbicide rotation, as that is a fairly common rotation in the prairies, so it gives us something to compare to. This is our actual numbers per square meter. Anything in green means it was not statistically different than the canola wheat 100% herbicide rotation. Anything in blue means there was a statistically significant increase in density. And so what you can see is that some of these treatments that had 3 years of no wild oat herbicides, utilizing primarily winter cereals and early cut barley silage, or the 3 years of alfalfa, had as few or fewer wild oats than the canola wheat 100% herbicide. So combining that diverse rotation with the winter cereals plus the barley silage in particular was able to drive some of those populations down, as well as the perennial alfalfa for 3 years. If we look at the wild oat seed bank, so this is actually digging up the wild oats in the seed bank, we see similar treatments come out. Again, early cut barley silage with winter cereals, or the perennial alfalfa was able to keep that seed bank low in terms of keeping it reduced. So what we're seeing is that cultural controls work quite well on wild oat. But what about for other weed species? What about broadleaves generally? If we just talk about broadleaves as a giant group, how well will these cultural controls work on them? What about twining weeds like wild buckwheat? That's one question that I've really had because it has the ability to climb. Does it escape some of those competition effects? And then will we see differences in broadleaf control by location or environment? So that was the end of some of Neil's systems work, which led into a study that I've led. Neil and I started together, and then I've taken over since he retired, where we combine similar treatments using perennial forages, spring barley, winter triticale or other winter cereals, barley silages with increased seeding rates and reduced herbicides. But we're also looking at chaff collection as a harvest weed seed control technique, and we're going to talk about harvest weed seed control more in a minute. And we're looking at not just wild oat, but also broadleaf weeds as well. Now, this study was completed in 2020, the field portion, so we're in just the preliminary analysis stage. So I'll give you some of sort of our preliminary conclusions to date, but there's lots more conclusions to come from this particular study. So the preliminary results, first and foremost, we saw way less management of wild oats than Neil saw in his previous studies. And there's a big question of why. I think one of the things that I really want to dig into more is we had a much higher wild oat population at the start of our study. This study started in 2016. We supplemented our wild oat populations just like what Neil did. However, 2016, I don't know if you guys remember, but 2016 was a very, very good wild oat year, or a very bad wild oat year, depending how you want to look at it. From the wheat scientist perspective, it was a really good wild oat year. There was a ton of wild oats. But that meant we started with really high populations of wild oats. And I think that may have impacted how well those management techniques work. So that's an area I really want to dig into. However, even though we saw less management, we still definitely saw benefits of winter cereals, barley silage, perennials, and increased seeding rates throughout the study in terms of managing wild oats. Those are tools and tactics that can definitely help. Again, they're not going to wipe out your wild oat population, but if you have a really dense wild oat patch, maybe you want to consider upping your seeding rate in that patch. Maybe you want to look at silaging, even if it's just that patch, or seeding that patch to a perennial for a few years, something like that, especially if you're struggling to figure out your livestock market or where you might sell some of those silage or perennials. Now, there were no significant effects of the various treatments on wild buckwheat. We did have wild buckwheat at all 6 of our locations in this study, and there was really no effect of any of our treatments on wild buckwheat density. Now, again, one of my questions is that due to that twining climbing nature of wild buckwheat? And will we see a similar lack of impact with a twining weed like cleavers, which means we're going to have to really look at some other potential integrated weed management options to manage some of those twining type weeds. Other broadleaves, we still need to do a multivariate analysis by species, so this is an area that we still need to work on. Each location at our 6 locations seeded broadleaf weeds that were common to their area. So in Lacombe, as an example, we put in cleavers, we put in hemp nettle, we put in lamb's quarters, we put in volunteer canola, we put in a whole bunch of broadleaves that would be common in our area. In Lethbridge, they put in kochia, right? Because that makes sense for their area. So we will have results on a number of other species as well. We just haven't had time to pull out those results quite yet. The other thing that was really interesting to see, adding chaff collection when all of the herbicides were pulled out for a few years didn't seem to make a big impact on the populations. However, in our treatments that were full herbicide rates, 100% herbicide over all the years, where we added chaff collection into those systems, that was the change that we made, was adding chaff collection, we were seeing decreased weed pressures. So it seems like that chaff collection is that additional step on top of our herbicide applications that can actually help manage some of our weed species. Now again, chaff collection here is used to represent harvest weed seed control. So I've talked about harvest weed seed control a couple of times here. I'm going to move out of the cultural control stuff and into harvest weed seed control now. So what on earth is it? Harvest weed seed control is a new paradigm of weed control that was really developed and refined in Australia. And the whole goal is to manage weed seeds that are still in the field at harvest and prevent their dispersal. So the combine harvester is actually a fantastic broadcast weed seeder. The weed seeds tend to be in the chaff, and when the chaff and straw is spread back on the field, you're broadcast seeding your weeds back into your seed bank in that field. And so harvest weed seed control aims to stop that dispersal and that re-entry of those weed seeds into the seed bank. Now, if we go back to this quick little diagram just quickly, instead of focusing sort of on this arrow or this seedling bubble, what we're trying to prevent is this big long arrow where those seeds that are produced by mature adults go back into the seed bank. So this is the arrow that we're now trying to target. Now there's a couple things that need to be in place for harvest weed seed control to be effective. The first one is the weed seeds must be retained at the time of crop harvest. So it's a little hard to see here, but if you look closely, you can see a bunch of little cleavers still on the plant here in this canola crop. So the weed seeds must be retained at the time of crop harvest. They're already dropped to the ground, they're already gone, we can't target them with these methods. Those weed seeds need to be produced at a height where they will be collected by the combine. No one really likes running their combine right at ground level. That's one of the issues that we've always had with peas when they lodge. And so if you can't cut at a decent height above the ground and still collect those seeds, then we're going to have a problem. The third thing is that you need to be able to collect the weed with the combine, which sounds a little bit ridiculous, but I got to spend some time in Australia when I was doing my PhD helping with some research there. And this is actually a picture in the field. And I know these are hard to see, but there's two really big bushy plants here. I believe they're called Indian hedge mustard. And it looked like they fit points 1 and 2 fantastically. The weed seeds were very well retained, and they were nice and tall in our chickpea crop, so it looked like it would be no issue to harvest them at all. But they were so round and bushy that they would actually roll up onto the header of the combine and off the side without actually feeding in. So as the header was spinning, it just spun over top, it rolled. And so I had to go back and add this. You have to actually be able to get the weed to go in the combine as well if you're going to manage them with these tools. Now, there are multiple methods of harvest weed seed control. I'm going to go through this quickly. This is narrow windrow burning. You collect the straw and chaff in a narrow swath behind the combine and you burn it. It was at one point the sort of most adopted method of harvest weed seed control in Australia. It has declined there. It's not one we really want to see catch on in Western Canada, even though it's very, very effective, because who wants that much burning happening in the fields? And no one lights a fire on purpose at harvest time in Canada. That's just crazy. You're just asking for major fires. The direct bale system, really interesting system, especially if you have a market for those bales. You bale the straw and the chaff, you take them off the field, and the weed seeds go with them. Nice and easy. I'm actually going to jump down to this bottom left picture. This is a chaff cart. So again, this is what we were simulating in our research plots. Chaff cart was actually a Canadian invention, more so for the collection of chaff for feeding for livestock. Didn't really catch on. However, the Australians imported them and they've made a few changes. So as an example, they're using these conveyor belt systems instead of a blower system. The chaff is collected in here, it's dumped in the field, and then it's either grazed, typically by sheep in Australia, or it's burned. So again, if you don't have livestock to graze it, maybe not something we really want to see catch on here because we don't want to see that increase in burning necessarily. These two pictures on the right-hand sides, they kind of go together. This is chaff lining and this is chaff tram lining. So the difference here in tram lining is that the chaff is put down in 2 rows behind the combine on the wheel tracks. This is typically used in a controlled traffic farming system. The chaff lining system, it's only put down into a single row behind the combine and it's not on a CTF system, it's just put down straight behind the combine. The idea here is that you are at the very least collecting those weeds so they're in one area of each pass on your field so that they're not spread across the entire field to compete with your crop, which makes targeted management a little bit easier. But the hope is also that you see reduced emergence of those weeds because of sort of a composting or a decomposition effect. That's something that's still sort of under some testing, but we are seeing quite a bit of adoption of this in Australia right now because it's a fairly cheap, easy way to get into harvest weed seed control. The 6th method that I want to talk about, and this is the one that we're hoping to see mostly adopted in Western Canada out of any of them, is the physical impact mills. These are a system where you can see all these various mills on the back of the combine. The chaff goes through those mills. The weed seeds are destroyed by going through those mill systems, and the chaff and the residue is put back on the field. So no burning, yay. You get to keep your residue and you kill the weed seeds. So that's sort of the idea behind them. These are the 4 brands that are currently on the market. This is the IHSD, or the Integrated Harrington Seed Destructor. I'll show you the original Harrington Seed Destructor in a few slides, and you'll see how much of an improvement this is that it's now built into the combine. This is the Seed Terminator. This is the Redicop Seed Control Unit, and this is the Tech Farm Weed Hog. So the IHSD, the Seed Terminator, and the Weed Hog are all produced in Australia. The Redicop Seed Control Unit is actually produced in Saskatchewan. Now, I talked about this being developed in Australia. Are they even bothering to use it? Yes. There was a survey of over 600 growers across Australia in 2016, so this is 5 years ago already. At that point, 43% of those producers were using harvest weed seed control. They were asked, by 2022, do you plan to keep using it or do you plan to start using it? And the expected adoption by next year was expected to be about 95%. It'll be really interesting to see if they follow that up and see where they're actually at. They were also asked, of those various methods of harvest weed seed control, which one do you think you'll use by 2022? And most people wanted to be moving to impact mills by that time. Now, we've also seen an impact on their weed populations. The most common weed that they worry about in Australia is annual ryegrass. And so this graph shows the effect in a couple of their focus paddocks. So they have fields that they go back to year after year after year and count weed densities. And what you can see is the solid line is including harvest weed seed control in those fields, and the dotted line is without harvest weed seed control. So the ryegrass population has come down altogether in both systems because of a really focused effort on including integrated weed management techniques. But with harvest weed seed control, the population comes down more quickly and it stays more stably at a low number than without the harvest weed seed control tactics. So I've talked about adoption in Australia. We don't see a whole lot of it yet in Canada. Why not? First and foremost, price is an issue. So the weed hog is the cheapest of the impact mills at about 50 to 60,000. That's the capital cost, including fitting. However, the Tech Farm Weed Hog tends to have an efficacy, from what I've seen so far, between about 80 and 85%. The Seed Terminator, the IHSD, and the Redicop Seed Control Unit, we're talking a price about $100,000. Now, the prices that I'm showing you here, these are from late 2019, early 2020. I believe those numbers may have come down a little bit further for something like the Seed Terminator. It's in and around 100,000 now. These are also Australian dollars, but Australian and Canadian dollars are pretty close. So it does give you a bit of an idea. So those 3 are more expensive, again, closer to that 100,000 K mark. However, they're hitting typically 95% efficacy of what goes through them or higher, so substantially higher than the weed hog to date. You might be wondering about this one down on the right, this other 50 to 60K one. This is an integrated Harrington seed destructor, but it's a single mill. These are all double mill units. This is not one that I would expect to see catch on in Western Canada because we have such a high yielding crop and more residue to deal with. So I wouldn't think that that would necessarily be an option for our producers. So those numbers sound really, really large, and I understand that. However, there is a farmer in Saskatchewan who has been kind enough to provide me with his actual solid numbers, including interest, his financing rates, his materials and supplies, his increase in fuel usage, his repair budget after running the seed terminator for 4 years. And he has worked it out on a 4,000 acre farm to be about $6.50 an acre. So if you start looking at it as a per acre charge, then it's a whole different ballgame. These numbers are hard to chew on up front, but if you start looking at spreading it out over your combine, you don't necessarily need to put it on every single combine. You just need to put it on the combine that's going to deal with your weedy areas, those types of things. Some of those numbers can come down a little bit. So price is the first adoption. The second one would be a lack of efficacy data on Western Canadian weeds, and I am working on that, and I'll show you that in a minute. The third one would be that it's not necessarily felt that it's needed. Most of our producers are finding their herbicides still work, at least most of the time, unless they're dealing with resistant weeds. But the more we continue to rely on those herbicides, the more resistance we're going to see, and the more quickly we're going to see a need for some of these types of tools. The other hope, I guess, from my perspective, is if we can have preventative adoption of something like this, we might be able to extend the utility of some of our herbicide tools a little longer into the future. So a little bit about the research we've done in Western Canada on this. We've looked at seed retention of multiple species, and seed retention is species dependent. So this is just a quick graph, preliminary graph from my PhD studies, but it shows really nicely that wild oat has less seed retention than cleavers, which has less seed retention than volunteer canola. So there is differences by species. That seed retention is also environment or year dependent. So this was in Lacombe in 2014. If I showed you the 2015 graph or the graph from St. Albert or Scott, Saskatchewan, they all look slightly different. So predicting seed retention can be difficult. It's also cropping system dependent. So in these particular studies, we had both wheat and faba bean crops, and where the retention percentage lay at harvest timing depended on which of those crops was involved, if we were taking it swath timing or direct harvest timing, all those types of things impact sort of where on the curve your harvest lands compared to your seed loss. So one of the things we've asked, again, I'm just touching really briefly on this, is whether or not we can manipulate our cropping systems for better seed retention. And what we're finding is that if you include more early maturing crops, so in our case we had peas and winter wheat, we could collect and manage more wild oats than in a canola wheat rotation or in a flax faba bean rotation, which were sort of our normal or our late maturing crops. So there does seem to be some potential to incorporate more early maturing crops or target our harvest weed seed control of species that drop their seeds early to earlier maturing crops to have a better impact on those populations. Now, we've done some stationary testing with the Harrington seed destructor. These were some pictures of getting to do this. So I mentioned how nice the built-in units are. This unit is the original Harrington seed destructor that was towed behind the combine. It's a very big, bulky unit. You'll see it on a combine in a moment. But we tested a whole bunch of things with the seed destructor, just stationary. So looking at things like weed species, weed seed size, weed seed number, a whole bunch of things, and grew out the samples. This is some pictures that I really like to show people of a before and after of the chaff that we were testing. So we use barley, pea, and canola chaff. And on the left-hand side of each of these pictures is the chaff before it goes into a mill system. And on the right-hand side is the chaff after it comes out of a mill system. So you can see that the term mill is really quite accurate because it comes out as a very fine powdery dust. And the vast majority of the weed seeds in there also come out in that fashion and are not really able to grow. So we've also done some preliminary testing of the Redicop seed control unit. At this point, we were testing a couple of different insides to their mills. They've obviously made final decisions on that since then, as well as chaff volumes. I'm not going to show you all of the graphs involved with all of these tests. I'm just going to give you the down and dirty conclusion here. If you can get it into these mills, you're going to have greater than 95% efficacy. So if you can get it into the mill, it's going to work quite well. The biggest trick is getting those weed seeds into the combine and into the mill. So our seed retention is likely to be the limiting factor for harvest weed seed control to be effective in Western Canada. And this type of work is very dusty, very dirty, and very itchy, just in case you were wondering. So we also have a field scale project with Harrington Seed Destructor. We had 20 producer fields involved in this study, and we had 3 harvests, 2017, 2018, and 2019. And we went back to the exact same spot in the field, and they were the weediest spots we could find in those fields. And we had 2 treatments, either Harrington Seed Destructor or a regular harvest, so that we can actually compare and contrast the impact of those 2 treatments over multiple years. To do that, we took weed seedling counts prior to in-crop spraying each year, and we also sampled the weed seed bank. So 2019 was our final harvest. 2020 was our last year of doing data collection, including sampling the seed bank. So I don't have final results yet. This is the type of work that we're doing for our sampling. This is an example of some of the soil that we collected that we then needed to grow out to determine what was in the weed seed bank. And so this is where we're at right now, is still growing out soil seed bank samples. I know it looks somewhat like a different type of weed grow up, but I promise it's seed bank samples. So hopefully we can get these results out soon, because I'm certainly very excited to see how it worked and what weeds it may have worked on. Are there potentially signs of harvest weed seed control catching on in Canada? Possibly. In 2018, 2019, there was 2 seed terminators that were running in Saskatchewan. In the 2020 harvest, there was 4 seed terminators running in Saskatchewan and 5 Redicop seed control units. And these are on commercial farms. These are owned by farmers, not the companies doing testing. In 2021, I know there will be up to 7 seed terminators running. I know Seed Terminator is shipping an additional 3 units. I would suspect we will probably also see additional Redicop units, being that they're located in Saskatchewan. So we could have up to 15 units running in Saskatchewan this harvest, which I know is not a huge number of units, but when it started at 0, when I started working in this area, 15 is very exciting for me. So I'm really interested to see if we continue to see that, and I'm sort of fingers crossed that more people are seeing the utility of this and may look at adopting this technology. I want to talk quickly about panicle clipping. This is again a wild oat focus, but you could look at it for things like wild mustard and lentils or other weeds that stick their heads up above the crop, essentially. So we want to look at managing wild oat seed set. Wild oat tends to show itself above the crop. Usually mid to late July, we start seeing those wild oat panicles waving. So the question that we asked was, could you cut the panicle off and prevent seed production? Any of you know that listened to presentations by my predecessor, Dr. Neil Harker, may know that he loved Far Side comics. And he found this one when we first started talking about this wild oat project, and now I have to include it every time because this is essentially what the wild oat does, and we're hoping to have the opportunity to cut off those wild oat heads and prevent seed set. So again, here, we're kind of in a sense targeting these adult plants, trying to prevent them from actually setting mature seed. So one of the big questions that we needed to answer was, when do those wild oat seeds become viable? Because if you're cutting a wild oat seed head off and all you're doing is putting viable seeds on the ground, then you're really not helping yourself at all. You're just getting the viable seeds to the soil earlier. So we did this in 2 crops. This is wheat, this is lentils. So wheat on the left, lentils on the right. And when we first started clipping, the way we did this, we clipped the panicles off, we kept the seeds, and we tested them for viability. So when we first started clipping, we had very low levels of viability, 0 to maybe 3 or 4% viability. But if you look, within 3 weeks, we are at about 50% viability. So it's not a very big window to actually cut those panicles off without putting viable seeds on the ground. You want to stay sort of in this early part of these curves, and that's not a very big portion of the curve. Now, obviously, you could get into lentils earlier. You could get into lentils when wild oat is at the boot stage. You wouldn't have to wait for full panicle emergence, and that's something that needs to be looked at a little bit more closely. But the big story here was, we really don't have a very big window for this to be effective. So that was the first study that we did, was when do those seeds become viable? The second one was how well does it actually work? So we clipped weekly from Panicle emergence in both wheat and lentils, and we did this in Saskatoon and Lacombe in 2015 and 2016. Then the year after we clipped in wheat and lentils, we seeded everything into canola, and we measured the wild oat densities, the wild oat biomass, and the wild oat seed bank. And surprisingly, in a lot of ways, we found no differences. So there wasn't a specific week that worked better in terms of clipping, and there really wasn't any differences between our clipping treatments and our untreated check. So it became a big question of why? What is happening with those wild oats that we're really not impacting them by cutting off those seed heads? Now, having said that there's no differences, I need to say really quickly that I'm not throwing this idea out yet. There are different methods of targeting the panicle. So another side study that we did showed that application of systemic herbicides could reduce seed set, but it's going to be tough to find a selective systemic herbicide that we don't already have resistance to and that isn't going to have MRL or other residue issues. However, there might be some other systemic products. That's something I want to play with. Is there a plant hormone, or is there some other who knows what out there product that might affect wild oats setting their seed? What about electricity? Electrical weeders are out there now, and wild oats stick their head above, so maybe you could electrocute the wild oats and actually prevent them from forming viable seeds. I don't know if it would work. It's something I want to play with. But again, trying to understand why the clipping isn't working, my best guess is that the wild oat is tillering. So you cut off that main seed head and the wild oat throws outside tillers that then set seed within the wheat canopy. So we might need to look at doing multiple clippings if those tillers are actually showing up above the canopy as well, or this may need to be really targeted to something like lentils, which is really short, where you can, without question, get back at those tillers multiple times in a field. Now, again, is this something that we necessarily want to do across an entire field? Heck no. But maybe we can do it in patches. Maybe if we have a really bad wild oat patch in our lentil, we can get in there and prevent seed set in that patch. That's kind of where we're going with this idea. I don't want anyone to think that I'm expecting them to go out and clip an entire field at this point. Right now, we're focusing on, can we manage those patches where maybe resistance is really developing? Now, there is equipment available to do this type of clipping. What's pictured here, this is the comb cut. It's a Swedish machine. This is actually being used in crop selectively to take broadleaves out of this cereal crop, but you can also lift it up and cut above a crop as well. We had some issues with our comb cut in Lacombe with getting it high enough to get above the wheat crop, but there is a 3-point hitch extension that allows you to raise it higher. We didn't have that at the time of our research. There is also a version, and I can't remember the name of it off the top of my head, from Borgo. It's a little bit different. Instead of having these stationary knives, it actually has like a spinning mower that you would just lift above the crop and essentially lawn mow the tops of the weeds off. And if you're thinking either of those doesn't sound all that much fun, I can also offer you the research versions of clipping, which is a handheld hedge trimmer or literally hand clippers. So these seem pretty darn good, I think, from the research perspective and from what we were doing in our research plots. Now, just some other things to consider in terms of non-chemical weed control. These are things that have been used in organics or maybe have been a little bit more acceptable in organics because we haven't needed to use them in conventional systems. But things like in-crop harrowing, cereal crops in particular can handle an in-crop harrowing, and it can be quite effective on weed species. Rotary hose. Inter-row tillage is one that I'm really intrigued by. All three of these implements have been studied a fair bit by Dr. Steve Shirtliff at the University of Saskatchewan. And both Steve and Dr. Martin Entz at University of Manitoba have worked on the inter-row tillage a little bit, but mostly focusing on the weed control side of things. My question would be, what are the impacts of using an inter-row tillage in a no-till or reduced till system? Having said that, you actually have plants and roots growing in an inter-row tillage. So you wouldn't think it would be as bad as a full-scale tillage, but I don't know. I'm just speculating. But it is something interesting. They do make them precise enough that you can go down to, I think, between 6-inch rows. So certainly achievable in our sort of 12 to 15-inch row spacing that many of our small grain producers are using. My main point, the whole point of this entire presentation, is that herbicides are not the only option, but it does require thinking outside the box. It does require using things that maybe you don't want to use. Maybe you don't want to increase your seeding rate, but it can be quite effective, or looking at a different crop in your system, or those types of things. The last thing that I'll point out is that all of those harvest weed seed control techniques from Australia, not a single one of them came from a scientist like me at my computer or in my research plots. They all came from farmers. They came from farmers looking at a problem and saying, what else can we do? And so I really, I guess, kind of challenge our Canadian farmers to, what else can you do to manage the weeds in your field, and how creative can you get? With that, I'm just going to finish things off with my contact information. Sorry, I'll back up. I am available and active on Twitter if you want to get in touch with me there. And I also have my email address on screen if you would like to ask me some questions or get in touch. Thanks very much for your time and attention this morning.
Great. Thank you very much, Brianne, for the great presentation. And before we start our question and answer period, I'd like to say thanks again to Bayer Crop Science for their sponsorship of today's webinar. We have a few questions here, so we'll dive right into those. Actually, one of the first questions here was, which weed species work best for the harvest weed seed control options?
So there's actually quite a few that work quite well. Volunteer canola, this is in terms of seed retention. Volunteer canola, cleavers, green foxtail, lamb's quarters, wild buckwheat. Kochia would work in terms of seed retention, although you might have to come back when they're not quite so green. Sort of leave it like a slough and come back and harvest it later, that type of thing. But there are a number of species that work really well. Ones that float away, so I'm thinking dandelion or annual sow thistle, do not work as well for harvest weed seed control.
Okay, so why, in regards to the mill options, why are we mostly seeing the seed terminator and the Redicrop adoption in Saskatchewan?
So the Redicrop one, I think, is fairly self-explanatory. You don't have to deal with shipping from Australia. You've got support right in-house in Saskatchewan, those types of things. Right. The seed terminator one is interesting. The first farmer that adopted it is actually a family relation to the owner of seed terminator. So I mean, when he looked at doing a mill option, he went with the family connection there. And then his neighbors saw his use of the seed terminator, liked how it was working for him, and so have adopted the same brand, essentially.
All right, perfect. Another question here. What has been the Australian real world data in terms of the durability of the impact mills?
So if you look at the first couple of years, the very initial models of the impact mills, not so durable. There was some issues with the materials that were being used, and there was a lot of replacement happening. As we move into model year 18, 19, 20, there's been substantial improvements to every mill with every manufacturer, essentially, so that durability has really increased. Talking to the farmer in Saskatchewan that's run his mills for 4 years, he's done very, very minor maintenance. He thinks he can get at least another year, if not a couple more years, before he has to replace some of those mill parts due to wear and tear, things like that. So durability has been fairly good since those first prototypes came out. The first prototypes, not so good. Newer prototypes have been really quite good.
Perfect. Yeah, that's great. They were referencing the maintenance costs and downtime during harvest. That could be another barrier to adoption. So that's great to hear.
Yeah, no, it sounds like the farmer that I've talked to a fair bit that's run his seed terminator in Saskatchewan, he budgeted, I can't remember what it was, something like $5,000 a year for repairs and supplies if he would needed it, and he's essentially not touched it over 4 years. So it's not a huge component of downtime or anything like that.
Okay.
Is my impression.
Couple more questions here. How many tons of material per acre do you think is removed with chaff collection?
Okay, so if I have my numbers right, the numbers that, and again, these are very much an average, and it depends how high or low you're cutting and everything else. On average, your your grain and your chaff is a 1-to-3 ratio. So if you've got, I'm just going to do this for easy math, 1 ton per acre of, or 1 ton per hectare of grain coming out, you'll have about 3 tons per hectare of straw and chaff produced, or of chaff produced. So through chaff collection, it is a fairly large, I think I have that backwards, 3-to-1. It's a 1-to-3 ratio one way or the other. I may have that backwards, and I apologize if I do. My brain's not fully engaged this morning. Either way, it can be a fair bit of residue that's removed through chaff collection, which is one of the reasons I've been a little bit hesitant. If you don't have a good feeding market in your livestock, that's a lot of residue and potentially a lot of nutrients coming off of your field.
Perfect, yeah. And so again, many of the cultural strategies you talked about do rely on having that livestock. So what can farmers do if they are not running livestock on their operations?
Yeah, it's a question I get a lot. And I think this might be where thinking outside the box may come into play a little bit. The direct bale system, they were able to, there was really one producer that took over the market because he really got well established with marketing it to people that did have livestock or exporting it. But think about your neighbors. Do your neighbors have livestock? Is there some type of exchange program you could set up? There's a farmer I've talked to in Manitoba who he exchanges land with a neighbor. The neighbor puts his annual cropped field into a perennial for 4 or 5 years, and he annual crops his neighbor's former pasture. He breaks the pasture and annual crops it for 4 or 5 years, and then they swap back. And that perennial time as a perennial pasture allows him to get his wild oats under control, and breaking the pasture rejuvenates the neighbor's pasture as well. So is there some kind of exchange system that you can set up? Or is there another market for it? I don't necessarily have a good answer. It's a tool we know that works, but figuring out how to make it work on your farm when every farm is different, that's a tough question for me to answer, besides be as creative as you can, I guess.
For sure, yeah. All right, and one last question here. Have you looked at the seed destructor as a way to manage crop residues?
Not in particular. So the straw itself is not touched by the impact mill. So the straw will be distributed as per normal. The chaff that comes out, it's a very fine material. We do see relatively uniform distribution from those impact mills, but we haven't really looked at it as a residue management thing. From what I've seen, the straw tends to be more of an issue than the chaff in terms of residue management. And so I don't see it having a big impact that way in terms of residue management.
Okay, great. Thank you, Brianne. Everyone, I think we've kind of touched on most of the questions here today. If you have any further questions following the presentation, please reach out to Brianne or to us, and we'll do our best to get an answer over to you. Before we end today, just a reminder that this webinar has been approved for 1 CCA CEU credit. So if you did not submit your CCA certification number when you registered, please email your first and last name and CCA number to webinars@annexbusinessmedia.com. And these instructions will also be found in the follow-up email, which will hold the recording of the webinar as well. Thanks again, Brianne, and thanks to everybody for tuning in to today's webinar. And don't forget to visit topcropmanager.com/webinars to view all of our previous and upcoming webinars. Take care until next time, and happy seeding. Bye now.